Hi there, this is Ms. McDonald for the weekly agenda for November 17th through the 21st for pre-calculus. So similar to previous weeks, this week you're going to be working on Delta Math. The topic is exponentials part 2. So you did exponentials last week, kind of introduced it, reviewed it if you've seen it before. So this week is taking that further, looking more at the graphs, doing regression, just doing various things with exponentials, solving different equations, things like that. So make sure you work on that throughout the week. If you turned in ACT number 6 last week, you should receive it back sometime this week and be able to do corrections on it if needed. Make sure you get those corrections done and turned in by the end of the week or whatever deadline Miss Lee sets. Make sure to also do your Math Plaza time, 30 minutes this week because this is a full week. And then on Thursday, you'll take a quiz. So that quiz will just be over what the Delta Math is for the week. If you look at the calendar, also on Wednesday, it'll be either Wednesday or Thursday, you might start an activity to kind of review and apply exponentials to kind of maybe review for the quiz or kind of just do a class activity related to exponentials. So that'll be on either Wednesday or Thursday, kind of depending on when it fits. But on Thursday will be the quiz, and make sure you get your corrections turned in. So let's take a moment to look at some notes and then also look at the Delta Math. So some notes that'll be helpful, especially for the first assignment on the Delta Math, is to understand the difference between arithmetic and geometric sequences and linear and exponential functions. So sequences are discrete, meaning they're just specific numbers, whereas functions are continuous. You could have any number in between. So you'll see this graphically on the Delta Math. But just as a reminder, arithmetic and geometric sequences are discrete, whereas functions are continuous. And then the difference between arithmetic, linear, and geometric and exponential have to do with that addition and multiplication. Remember, arithmetic or linear functions, those have a common difference where you're adding or subtracting. And geometric sequences and exponential functions, they have that common difference where you're multiplying by something. And sometimes you see it as like dividing, that's technically multiplying by a fraction, but it's that multiplication. So let's look also at, on your Delta Math, you'll have some half-life and doubling formulas, problems with those. And these are the formulas that you're going to want to use. So you may want to write these down in your notes. So let's look at the Delta Math. Okay, so in the Delta Math, like these first few problems are really going through, like, is this an exponential graph? Or is this, so this is continuous, right? It's a curve or a line, whereas discrete are going to be discrete points. You'll see points and stuff. So anyway, that you can watch the video and go over that. When you get to this one, with these, you're going to be filling in the table. So what I would do is start with this first point. So when you plug in -4, what's -4 plus 1? That's -3. Okay, so then take that, -3 is now the exponent. So do half of -3. Or sorry, excuse me, it's 1/2 raised to this power. So 1/2 raised to the -3rd power. So you can use your calculator. I'm going to use Desmos here. So 1/2 to the -3rd is 8. So I'm going to type in 8 and then hit try. And if it's correct, it's going to give you the next line, and you'll just keep doing this. And what you're doing is you're creating a table of values for your exponential function. And then once you have that, you'll then plot some points from the table that you created. Same idea here. The only difference is it's just one more step. So there's another transformation. So instead of just having maybe a vertical shift, it may also have a horizontal shift. So there may just be additional transformations on that. On this one, this is one continuous table of values. This is not 3 different tables. Sometimes that's a little confusing. It's kind of sectioned into 3, so it's just not one long, big, long table. So you can see it goes from like -10 to 4, and then -3 to 3, and then 4 to 10. So this is all connected. These are not 3 separate tables. So you're looking at the asymptote. So it's the value that you're approaching, getting really, really close to. So look at your y values. See how these y values, as the x values are getting smaller, are getting closer and closer to 0. It doesn't actually get to 0 because it's an asymptote, but you would click your asymptote. And then you come down here and you plot points. So again, the table of values is given here. So for mine, like 4, 1, 5, 2. Again, plot all the points and then you'll submit it. I think you need to do at least 4 points. So you can do more than that, but at least 4 points. For the half-life and doubling problem, it'll tell you in the problem if it is growing, so doubling, or if it is decaying or depreciating, so half-life. So on these type of problems, that's where you're going to want to use one of these 2 formulas, just depending on which problem you have. T is representing the time, so that might be the number of years, the number of months, the number of days, whatever the unit of time is in the problem. And then if you're doing a doubling, this D represents the doubling time, whereas if it's a half-life, the H is representing the halving time. So for example, in this problem, it's saying it is doubling every 9 years. So the doubling value is 9, whereas the time is 29. It's the T. Okay, on this one, various forms and units, very similar. Again, if you want to see an example, you'll watch the video, but if you want to see an example, there's examples in the formulas that you might need. When you get to exponential between 2 points, so you have 2 points here, this is the form you want to type it in as. So based on these 2 points, you want to come up with the equation. So using the 2 points, you can identify the common ratio. You can kind of plug in what you know, solve for what you don't, and then kind of go from there. So again, you can watch the video on that. And then on the last one for regression, regression is not hard. It's kind of like line of best fit, only we're doing exponential. So it's like a curve of best fit. The thing with this one that students mess up on is the rounding. So it's not a hard process, but it's the rounding. So like on this problem I'm showing, this one, we want to round all the coefficients to the nearest hundredth. So that would be 2 decimal places. Remember, tenths is 1, hundredths is 2, thousandths 3, so on and so forth. And then I'm going to use that equation and determine the value of the car to the nearest cent. So that's, again, 2 decimal places. So usually rounding is what messes people up. So you can use the calculator that's shown in the video. You just hit copy value, open stat calculator, paste, and then you're going to come here and do the calculate menu. And we want to do the one that's the exponential. So it's the EXP reg, exponential. You can keep the diagnostic on or off. It doesn't really matter. I'm going to hit calculate. And this right here is my equation. So it gives me the A value. So it's this 13,052.71 if I'm rounding to the hundredths. And the B value is 0.89. We can round that up to 0.90 to be two values or 2 decimal places. And then the X is what I would plug in. Well, first I would type in the equation. This would be the equation. So it'd be Y equals the equation. And then use that equation, and where my X value, the exponent, will plug in 11, and then I'll type in the number here. So again, it's not hard, but the rounding is usually what gets students. So hopefully that's a good overview for your Delta Math, and I hope you have a great week. Thanks.